Alright, let's get started. Today we'll be going through an example which is based around city services, and specifically how service requests get fulfilled through city departments. The main data source we're going to be using is known as the 311 call center. It's a widely used non-emergency service request center for city and local governments. We're going to start from scratch just so you can see how quickly and easily it is to pull some of these records specific to the certain timeline cases and load these onto the tool and begin analyzing and uncovering some of the mysteries within the data. So the first thing I would do to get started is reach out to my CSV file that contains the city services data. It's one of the simplest forms to be loaded onto the TimelinePI tool. It's worth mentioning that these timelines can be assembled from multiple files that all correspond to different systems of record. So when you imagine all the different departments within the city or even contractors and those sorts of things, they all maintain their own records and their own data. The tool is able to compile those all together. So we're able to connect them through something known as the timeline ID, and this is unique identifier. Before I go into that, I just want to show you that there's three fields which are absolutely required to get started. The first is the timestamp. This is simply going to tell you when an event happened. The next thing is that unique identifier, the timeline ID. This is going to be the way to join together all the events in a given process instance. It's going to put that all into the same context. So think of this as a customer ID, maybe a citizen, a claim number, or a service ticket number. It's any type of unique identifier which signifies what we are looking to measure. And then lastly, the event name. And this is just going to simply tell us what happened at that step. This will tell us the work that was completed. So something like the request was submitted, the work was completed, those sorts of things. Those are the only three required fields that we'll need, but we'd probably want to also bring in additional fields, and those are sorts of things that I have here in the purple. And those are other ways that you may consider as dimensions. These are ways to further filter and slice and dice and ways to break down the data by. So you can see we'll use things like department and the problem type, the intake funnel, so that's the way that these issues were reported, unit IDs, citation numbers, even ways to break out and look at employee, the location, even the city council district. So once we've mapped some of these columns in the file, we now simply hit the confirm and start upload. I've already done that for this demonstration today. But if I had not loaded the data, it would have taken about 75 seconds to load what we have, which is about 305,000 events related to these non-emergency service requests. And in that time, the tool reverse engineers the entire process, builds all of the models, and creates multiple forms of analysis. Once you load the data onto the tool, we're then presented with an overview page. This is going to include quite a few metrics which are going to give us a better understanding and a better overview of our project and the data we've uploaded. So the first thing I want to point your attention to is that we have roughly 305,000 events, and they've been loaded and mapped to approximately 29,000 timelines. In this case, these are service requests, so we have close to 29,000 service requests that we're going to be looking at. We've pulled out 16 different events from that data. I can pop these out here and you can see them all listed. The other thing is that I can filter these and begin to dynamically change how I view these based on the number of occurrences that these events happen, the number of timelines that they occur on. And then the other thing is I've loaded some icons in here. You can see I've uploaded my own. It's going to allow you to pinpoint specific events or critical touch points in the workflow. You can upload your own. You can use colors that are able to identify. It's just a lot better than the little circle with a number on it. These are going to be ways to really just when you're scrolling through the timeline view, and you're going to be able to pop out and see exactly which events, and it's just a good way to identify those events. So there are also some metrics which have been automatically calculated from the data on this overview page here, and then of course these analysis tools. These are the tools that we'll be using as we further filter and break down the data. So some of the metrics that we have here include the duration of these service requests, the count of events that happen on these service requests, the count of unique events, the time gap, and then we also have some things that show us the first events that happen and how likely these events are to be the first event, and also for the last event, and it gives you a percentage from the data of when these are and how these are occurring. These are things that are going to be shown on the overview page. The next thing I'd like to show is the timeline view. This is going to be a a broad overview of actually all of the processes and all of the city service request. So each of these different lines with the circles on them is going to represent a different encounter or a different service request. Each circle represents an event or a step in the process, and those are the icons that we've uploaded, as you can see. So as I scroll through these timelines, you can see that each timeline is different length from the other. What this is that they're proportionate to the elapsed time of the actual process. So of course some are going to be longer than others because some took longer to complete. It also is going to include the gaps where nothing has happened. So we can probably start to see some glaring examples where bottlenecks may be occurring, or maybe repeated processes, and just ways that there might be some process inefficiencies. And then if I click on any one of these, I can then begin to see a more detailed view of the process. So this screen here is the timeline instance detail screen. This is going to give me a good way to look at a specific timeline. So as you can see here, it's timeline number X, or service request number X. The column all the way to the left here is the superset of all the events which have occurred with this specific request. We can see that there's an issue reported, case open, but there's some other things here, that aren't always found on timelines. Issue inspector assigned, issue found. These are sorts of things that are mutually exclusively happening together. Steps where the tool has automatically detected those done as sub-processes or parallel processes, and it's grouped them out together. So, like I said, every request should probably have the issue reported and then a case open, but not every case is going to have a work inspector assigned or a work inspector scheduled. The tool has uncovered that and then grouped these together as sub-processes. This screen that we're looking at now is a very micro view of the process, as opposed to the previous timeline screen, which at first is a very macro view and gives you a really good look at exactly how the process is happening. But the detail we have here could be useful in looking at and uncovering the root cause of compliance risk or workflow inefficiencies. It's a good way to find out the detail of that service request. So if you're thinking about loading up data from multiple systems, this here is going to be the way to essentially pull together the composite lifecycle of this specific service request from the time it gets received by 311 to the completion of the work and the resolving of the issue, closing the case throughout the different departments, so regardless of the system of record which is responsible for recording these events. So the tool, the engine itself, doesn't know anything about the service request. It could just as easily have been doing this with any other type of industry application. It's totally agnostic to the industry. The idea is just to give users a much better understanding of what's going on in the process, no matter what type of vertical is being supported. If you go into the timeline view, we can see that each one of these are very different. So to break out and see the detail there is a good way to uncover some root causes of problems within specific service requests. So the next thing is that you might ask if there's some sort of way to map a process diagram that would explain generally how things are working overall, not for a specific timeline, but for all of the events within the data. So this is a question that most business users struggle to answer with their existing technology. It's a big reason why most people can't tell you with a high amount of confidence exactly how their processes are being executed. We have a good tool to solve that problem. It's the process schema. This here is going to give you the capability to visually map the most common path through the process. I have one that I've saved from earlier because you can save these and view them later. So I save this one here as city service response process. And then we're going to see that this isn't just a Visio diagram. This can be saved and used as a monitoring tool. I can edit it, initialize a new schema, and show you the events that I've chosen or the milestones that I've chosen to be included in this schema. When I save it is when it actually becomes the monitoring tool. And that's going to show me exactly how the process is flowing and what events are most commonly occurring in a specific place. So the tool is using advanced statistical analysis and specifically choosing which steps are most reliably and commonly occurring the same place in the process. So this is showing that this is the most common schema based on these milestones which I've said we care about. So as I said, not just a Visio diagram. You can save it and then begin to use it as a monitoring tool. It tells me what number of cases follows which paths and where time is being spent. So you can see the thickness of the lines here is the number of transitions that are going through here. So there's not a lot of where issue was unfounded, but there certainly is a lot here where issue was found. and that's where the process continues on. But also we can see the time length of transition, so how long it took for the next step to occur. The thickness of the lines shows that there was a much longer duration during that time. The next thing that is a cool tool to use here is a way to better understand where steps that generally might not always occur in a specific part of the process most often occur. So with this specific data set, there's some times when citations are issued. And that's going to be a time where, the issue was found and then an inspector issued a fine. So something like the lawn wasn't mowed, so they fined the homeowner for that. So you can see here there's a 56% chance that the citation is issued right after the issue is found. But there's some other places, and we see down here and even at the bottom before the case is closed when a citation gets issued. Those sorts of things would be interesting for the business process user to understand exactly where these things are occurring and how and when they're occurring. It's going to give you a much better understanding of how these service requests are getting assigned and moving through the city departments, and when events are likely to occur, such as that citation being issued. Overall, it's first and foremost a good tool to use just to gain a better understanding of the existing workflow. Another way to find where bottlenecks may occur, because we're going to be able to see the time length of transitions, the number of transitions that are going from one event to the next. And it's also going to be another way to look at and get a better understanding of the process and the process flow that's actually happening within the data that we have. The next thing I'd like to show is actually the path analysis, and that's going to be showing us exactly how these things are occurring. So you can see here, this is going to give us a way to easily begin analyzing the timelines that we have here. Lean, Six Sigma, and process owners are really going to like this type of data. The tools is showing exactly how the process was completed with the most commonly followed paths here to the left. And it's going to clearly expose where steps have been skipped over, done repeatedly, or totally out of order, with the most common paths highlighted for us. So the tool has suggested the steps along the left, but we can make changes to that and dynamically change the way that these paths flow. It's going to be recalculating the percentages of processes along the top, which have gone one way versus the other. And the ones to the left probably shouldn't come as much as a surprise, because these are the most commonly followed process paths. But scrolling to the right, you'll begin to see some crazy things where there's more and more unusual or obscure behavior where things are jumping around and skipping steps. And then maybe we spot some glaring issues that probably shouldn't happen. We know that these things should happen one way, and maybe we have a compliance or an efficiency risk. And I can actually apply that lane as a filter. And when I do, I'm now only shown those 514 timelines or city service requests that are relevant to that followed path. So this is one here where an issue is reported, case open, unfounded, and closed. I apply that filter, and then I can look at the timelines where that's happening. It doesn't mean that every single event and every timeline is exactly identical here. It just means that each instance contains the specific milestones that we said we cared about within that filter and shows exactly how they've been executed. The goal with this tool is to promote continuous improvement. As you see as we go along, filtering and looking at the timelines like this will become a theme as we go along. We can start with a large data set, and then we'll begin to whittle it down to more manageable sizes. In certain cases, we're going to build in our own conditions, and then sometimes we'll let the tool do an analysis on its own. It's just a way to try and uncover weird or wonderful things that are occurring within our data. There are nearly 29,000 cases in my current set, which is just too many to scroll through and be able to digest. So we can use the metrics along the top to get a better understanding of the data that we're currently looking at. Because these metrics are always going to be representative of the set of timelines which you see in the window here below, you will see these recalculate and change dynamically as we further filter and break down the data, as you can see like we did with the path analysis. So right now we're looking at close to all of the 29,000 service requests. Looking at this duration metric here, I can see that there's at least one case which took through about 3 months, while there was another one that took less than a day to complete. And that's something I think is a little odd. So those are some extreme differences. I'd like to drill in that and take a deeper look. So here I'm presented with the histogram, which shows me the distribution of my cases by their duration. Fortunately, we have a lot of the cases which are done in less than 3 months, but I can show you that I can dynamically adjust this slider and begin to see where these are occurring and how the duration is lasting. I can see that if I slide this to 1 month, I have nearly 36% completed within 1 month. but another 63% outside of that, which are taking more than 1 month. I can then apply this filter and see just the ones that are taking over 1 month. And then I'm presented with these nearly 18,000 or so timelines that are taking longer than 1 month to complete. In working with this local government, they were interested in cases that were taking longer than 1 month because that was what their SLA times were. And working with this government, they were concerned that work was being performed was insufficient and sometimes needed to be completed repeatedly. So here we can quickly see that they were absolutely correct, and that some of these work completed steps are happening not once, but sometimes twice. So we can apply that again as a filter, and then we see that there's nearly 4,300 or 15% of the timelines where work is being completed more than once. And then we have that repeated work step where there's wasted time and possibly wasted money, where these things have to be happening repeatedly. So these cases are going to show us exactly where those things are. But we can get a bit more quantitative and figure out exactly where time is being spent for work to be completed by using the time interval measurement tool. So as I bring up the time interval measurement tool, it still has my settings from earlier. I specify that the starting event is issue reported and the ending event that I want to look at is work completed. I want to know how long it is taking to complete the work to complete the service request. The city expects that the work should be completed in 1 month, but as we've already shown, that is not the case. As always, we'll be shown the minimum, maximum, average values as well as the distribution here. So the average time in these cases when the first work is completed is nearly 26 days. The last time work is completed actually changes. So we can see that this actually moves to 30 days, which is right around that SLA time. So then there may be some questions too about why some of these are taking close to 2 full months before closing. Repeated work is probably the culprit here, as we've seen. You can then zoom in again, of course, like we showed earlier. We go to that 1 month, apply that filter, and be able another way to see exactly how those things are happening. The next thing that I want to look at is our query tool. The query tool is going to be very important when it comes to looking at to find things by their history. For instance, what if someone were to ask how often does the specific scenario happen where we have things that probably shouldn't happen, but we can hypothesize and look further into. And I want to look at something where, there is an issue that doesn't get found, but work on that problem gets completed. And I can go through here and say that, well, the issue was never found. And it's not to say that the issue was unfound. There's no record of any of that. And it certainly could be unfound as an event. But just to see that the issue was not found and then there was some work that was completed. Seems like something that really shouldn't happen. If there was no issue that was found, there should be no work to be completed for that problem. So by testing it out, there's a way to search that and find more information about it. We can see that there's nearly 3,300 timelines that have that exact query that we searched. The cool thing is that it doesn't have to be simple. We can do a further search and find out more and dig deeper with some more complex searching tools. So people always think that there's waste in city departments or sometimes abuse by government employees or maybe just overall bad record keeping where employees don't document their work properly. And of course, if work isn't documented properly, departments tend to not receive the proper funding and it's just a whole mess. So I want to build out a query where these things aren't happening, and I want to look into where the case was never opened, the issue was never found, and how about even where the issue was never reported. But then there was some things that had happened with work, and let's say just anything, whether it was the work inspection approved or disapproved, the inspector was assigned or work was started or work to fix was scheduled, anything that has to do with work, saying that these 3 things didn't happen, but that one of these things happened after that. And then I can search that and see that, okay, we have nearly 2% of the cases where there was no case opened, no issue found, and no issue reported. But there's these things here that happen with work, and that could just be bad record keeping. It could be, misdocumentation of cases coming in, or these departments that are handling requests that aren't in this system. So it's something that was done extremely quickly and easily. The beauty of this is that the queries absolutely do not need to be trivial.